4.1 Day 2 notes, we're still going to be working on basic graphs. And today we're going to be adding in tangent and the reciprocal functions. So today we're going to start with a tangent of x for the values of negative pi over 2 to 3 pi over 2. And then we're going to find the x values for which tangent of x equals negative 1 between negative pi over 2 and 3 pi over 2. So to start with, we're going to fill in this table of values. And again, just like yesterday, we're going to use that unit circle. And we're going to use these to figure out what tangent of these values equals. So remember, each coordinate point represents our cosine and our sine of those values from 0 all the way around to 2 pi. And if you remember back to a few chapters ago, we talked about how tangent was equal to sine over cosine at that value. So we're going to set up those fractions and use those to figure out what our tangent equals. And again, just like last time, we're going to start with these values. So negative pi over 2 is going to be the same as 3 pi over 2. And we're going to do 0, pi over 2, pi, and 3 pi over 2. So if we were to find the tangent of negative pi over 2, that would be negative 1 over 0. And anytime we have something over 0, that's going to be undefined. Then if we go to the tangent of 0, we're going to have 0 over 1. Which is just equal to 0. So we're going to have the coordinate point 0, 0. And then if we have the tangent of pi over 2, we're going to have 1 over 0, which again is undefined. And then the tangent of pi, and that is going to be 0 over negative 1, which is just 0. And the tangent of 3 pi over 2. And just like last time, that will be negative 1 over 0, which is undefined. Now we can go ahead and find the rest of the values that we were looking for. Tangent of pi over 4, negative pi over 4, 3 pi over 4, and 5 pi over 4. So those are going to be using our special right triangle. So if we were to start with the tangent of negative pi over 4, we would have negative 1 over 1, which is just negative 1. And that gives us another coordinate point to use. And the tangent of pi over 4 in our first quadrant is 1 over 1, which gives us 1. And then moving on to our third quadrant, we would have 1 over negative 1 for 3 pi over 4. Oh, nope, it's supposed to be a comma. And lastly, if we do 5 pi over 4, we would get the tangent of negative 1 over negative 1. Which simplifies to positive 1. Now that we have all of our coordinate points, we can go ahead and draw our graph. So this one we went from negative pi over 2 to positive 3 pi over 2. So we have 3 pi over 2. If we cut this into thirds, we would have pi over 2 and pi. And we went to pi over 4 on our table, so we're going to cut all of those sections in half again. The first thing that we're going to talk about is anytime we had a term that was undefined. At these values, whenever tangent is undefined, there's going to be an asymptote. And an asymptote is a line that we're going to use to help guide our graph, but it's not part of the graph. So we're going to label it or draw it with a dashed line. And a lot of times that's just abbreviated ASYM for asymptote. So we're going to have one of those at all of the x values for where tangent was undefined, which starts at negative pi over 2, and then pi over 2. And then the third one was at 3 pi over 2, which I've already drawn. Now that we have those drawn in, we can plot our other coordinate points. So tangent of negative pi over 4 is negative 1. If we add those coordinate points on our graph, be negative 1. Tangent of 0 is 0. And the tangent of pi over 4 is 1. And when you draw in your graph, make sure the lines do not cross the asymptotes. So this would be one complete period of our graph. So a period for a tangent is between two asymptotes. So our period for this one is equal to pi. And a tangent doesn't have an amplitude because it continues to go up and down. And then if we were to graph our next section, we would go to 3 pi over 4. Oh, and I missed a negative sign there. Sorry about that. So at 3 pi over 4, we're going to go down to negative 1, then 0, and then positive 1. And that would give us the 3 points for another full period of our tangent function. Then once we have our graph, we can go ahead and answer the question that they asked. And for what values does x equal negative 1 between this range or domain? And that would be x equals negative pi over 4 and then 3 pi over 4. And that would be our x values. And that's what it looks like for a tangent function. Now we're going to do some reciprocal functions. And when you have a reciprocal function, the first thing you're going to draw is either our sine, cosine, or cosine function. So the reciprocal of cosecant would be sine. So for this one, we're going to start by drawing a sine function. And we're always going to want one full period. So like we talked about yesterday, the period of a sine function is equal to 2 pi. And if you need, you can go ahead and draw that unit circle and those 4 coordinate points if those are helpful for you. Or if you're at the point where you don't need that anymore, you can go ahead and skip this part. 0, 1, negative 1, 0, and 0, negative 1. And again, we're doing all of the sine values, which are the x coordinate points. And if you forget, this goes from 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. So working our way around that unit circle, we can draw in our sine function. And because this is just going to help guide us, we're going to use a dashed line when we draw this graph. So once you have all of your coordinate points, we're just going to do a dashed line between all of these points. Oh, I put my negative 1 really far down. Let's move that. Okay. All right. So once we have our original function or our sine reciprocal function graph, step 2, we are going to draw in our asymptotes. And those are going to be wherever sine equals 0. So our asymptote is going to be at every spot where our sine function happened to equal 0. So in this one, for one full period of our sine function, we're going to have 3 asymptotes. And then lastly, once we have our asymptotes drawn, we're going to draw our graph, our final one. And these reciprocal functions for cosecant and secant are just going to be parabolas opening up and down at the maximum and minimums of our reciprocal function. So these green lines are exactly what our reciprocal functions would look like for cosecant. Wherever we have a maximum, our graph is going to open up, and wherever there's a minimum, our graph is going to open down. And both of these together make one full period. So you need to have one that opens up and one that opens down for a full period of a cosecant. Now let's go ahead and look at what a secant graph would look like. So step 1, we're either going to graph sine or cosine as a reference. Because this is secant, we're going to graph cosine. La-di-da. And if we have 2 pi, we cut that to pi, pi over 2, and 3 pi over 2. 1 and negative 1. And we can use that same unit circle that we drew up here, but this time we're looking at the x-coordinate points for our points on our graph. So cosine starts at 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and then back up to 1. For this one, just so we have a full cycle going from 0 to 0, I'm going to add another dash going to 5 pi over 2, so we can add on another point to our graph. And when we graph our secant function, you're going to see why I did that. So we're going to go ahead and do my dashed lines all the way down. There we go. And then just like with our cosecant, step 2, we're going to draw in our asymptotes. And that is everywhere that our cosine equaled 0 is going to be an asymptote. La-di-da, draw those up. Okay. So we do have 3 asymptotes again. And then our last step, step 3, we're going to draw our final graph. And just like in cosecant, our final graph is going to be opening down at minimums and opening up at maximums. And they're never going to cross those asymptotes. So this is why I added that extra point here over on the right, so that you could see a full cycle in between asymptotes. So that would be one full cycle, the highlighted lines that I did for our secant graph. All right. Our next one, this one is cotangent. And for this, I know on the last ones we drew our reciprocal functions first. For this, as a reference, I'm just going to draw our tangent y equals tan of x between negative pi over 2 to pi over 2. And I'm going to draw this on a separate graph because it will get pretty full if I do it all on one graph. Pi over 2 and negative pi over 2. And just if you look back at our number 1 graph that we did for a tangent, we had an asymptote at negative pi over 2 and pi over 2. And then we had 3 points, one at negative pi over 4 at negative 1, 0, and then positive 1. So this is y equals the tangent of x. And what we need is to draw cotangent. So again, just like before, anytime our original function equaled 0, we're going to have an asymptote on our reciprocal function. So for this one, if you look, tangent equaled 0 at 0. So that means we're going to have an asymptote for our cotangent at 0. Our period is still going to be the same as our period for tangent, which our period for tangent was pi. So our period for this one is also going to be pi, which means our second asymptote is going to be at pi. And if we were to look at our unit circle, so if we just draw our unit circle over here, we would need to figure out what cotangent is at pi over 4, which would be 1, 1. And cotangent is our adjacent over our opposite side. So cotangent at 1, 1 is going to be 1. Get rid of this blue dot there. Don't need that. So our first point is going to be up at 1. And then if we were to find the tangent at pi over 2 up here, cotangent, this is 0, 1. Remember, tangent is sine over cosine, so cotangent is going to be cosine over sine. So for this one, it's going to be 0 over 1, which just equals 0. And then, that was pi over 4, we need to find the cotangent of 3 pi over 4, which is going to be in our second quadrant, 1, negative 1. So our cotangent is going to end up being negative 1. And this would give us one full cycle for our cotangent. And this pattern would just continue on. We would have an asymptote every pi units, and then we would have the same graph just copied over, moving to the right and to the left. So when you're graphing cotangent, it might be confusing to graph tangent and cotangent on the same graph. And realistically, you don't need to graph tangent in order to get cotangent on your graph. So if you were to just use the unit circle and find the cotangent using cosine over sine, you wouldn't have to graph our original function like we did for secant and cosecant. All right, if you have any questions on these, please let me know and I'll get back to you as soon as possible.